Hi, welcome back. So in this short video we're going to take a look at how to add an SDN gateway using a virtual vMX into our OpenStack all-in-one cluster. So this is the cluster that we deployed in the previous wiki. You can see that I'm running the stack already. And this cluster gave us a test setup of OpenStack, Contrail as the SDN, and deployed it into AWS. If we look at the wiki that we followed previously, here's the architecture, a Contrail command instance, an OpenStack all-in-one. So before you start this next wiki, this stack should already be deployed, and you should already have followed all of the steps which walk you through building some test networks, net 1 and 2, and deploying some instances into those networks. So what we're going to add today is an SDN gateway. So Contrail can talk to many different gateways. The vRouters themselves can break out to underlay. So for example in AWS you can just configure networks in the SDN and say you can route out on the OS. Same for ingress traffic. So you could deploy an AWS load balancer and you could just point it towards a vRouter in order to find your overlay networks. And then of course Contrail can use an vMX router as an SDN gateway and QFX, leaf and spine. So what we're going to do today is a little bit different. We've configured the OpenStack cluster in AWS already. Juniper has a virtualized version of the vMX gateway called the vMX. It's available in AWS as an AMI. So we're going to deploy using CloudFormation a vMX into our existing AWS stack. So it's a brownfield CloudFormation. It will deploy into existing networks and an existing VPC running OpenStack. We're then going to use Contrail Commands Fabric Manager to find and provision the vMX as an SDN gateway for us. And then we're going to connect between instances in virtual networks in Contrail's overlay and EC2 instances in AWS. So these appear as underlay. The vMX SDN gateway is going to do a translation between underlay networking and overlay using MPLS over GRE for the data plane, so tunnels, and BGP as the routing protocol. Now what I show you today is a little strange in that we're doing Junos MX in AWS. It's not your typical use case, but there are a couple of advantages here. One is it gives you a playground, somewhere where you can use OpenStack, Contrail, and an vMX router as an SDN gateway, all automatically deployed into AWS. The second is it will show you tricks that you can also use for on-prem, so you can apply the same steps that I do here, but you can apply them to a physical vMX on-prem, and then point your AWS cluster or your on-prem cluster towards it. So same steps, same fashion. And it also leads into quite an interesting use case that's come up with a few customers recently. They're already deploying a large number of on-premise clouds using OpenStack, OpenShift, Kubernetes, etc. And they want to stretch networks in those overlay SDNs all the way into AWS and then break out to EC2 instances in underlay. So this gives you a way to do that. We're going to look at that in a separate short video after this one, but this is certainly the steps that lead up to that. So the diagram here shows you what we're up to. AWS OpenStack cluster as we previously deployed. We're going to add an SDN gateway and we're going to have it doing underlay overlay routing. So in the wiki I've included a second diagram here. If we click it and take a look, this gives the OpenStack deployment in grey. So this is the deployment and the stack that we've already ran, and shows you exactly what we're going to add. So you can see the Juniper vMX gateway. We attach the interface called FXP0 to our public subnet for OpenStack. We attach an elastic IP so that we can SSH to it across internet. You have the same opportunity to control that access using security groups with a variable in the stack. We then connect interface GE000 to our private subnet. This is the subnet where we're going to be doing control plane traffic, BGP, between the Contrail SDN controller as well as overlay traffic, MPLS over GRE in this case. So there's also a knob in the CloudFormation stack to say whether or not you want to deploy a bare metal and a bare metal subnet. So we'll deploy a subnet, which we're calling bare metal. We'll connect it to interface GE001. If you select the box, deploy a test instance for you in that subnet, a route table, and in that route table our default route will send all traffic via the MX. The vMX will also use a loopback address, so the stack will modify route tables in OpenStack, security groups in OpenStack, as well as creating new security groups and route tables so that the devices can all reach the loopback and everything works. So simply following the wiki, it gives you that initial warning that you should have already followed and deployed the OpenStack all-in-one. And of course, once you understand how this works, you can deploy this stack into any cluster, into an OpenShift or a Kubernetes or something you've cooked yourself. So we can do a click to launch stack. I've also given an example command with the parameters so you can run it in AWS CLI if you prefer. As this is the first time you've seen it deployed, let's launch the stack with the graphical user interface. So as usual, all parameters can be modified. I've given explanations in the stack of what they do. You can see, for example, true, and we deploy a bare metal test instance for you. So there's a yes, no. Uses the usual SSH key. I've pre-provisioned the networks to match the OpenStack stack you've already deployed. As ever, all of the parameters can be modified by you, but I suggest you deploy with the defaults for first run. Now for parameters that you must configure, you can see at the bottom some parameters starting in ID. So as I mentioned, this is a brownfield stack. We'll look at the greenfield later. So it's not creating these resources, it's sitting within existing subnets and within an existing VPC. And that's because we've already deployed the OpenStack CloudFormation. So you need to populate these to tell it where to sit in your AWS account. So let's do the VPC ID first. So here you can see the VPCs that I have in Ireland. And here is my VPC that was deployed for OpenStack. So I'm going to take the ID, populate it into the stack, public subnet. So again, go to VPC, find the subnets, and here's the OpenStack public subnet. Whilst we're here, we may as well do the private subnet. So the public subnets really are just used for access, admin access from internet. The private subnets where we do our BGP signaling and our MPLS over GRE overlay tunnels for data plane between OpenStack and the SDN gateway. So here's the private subnet ID. And if you specify the route table ID that OpenStack is using, then the stack will modify it for you and inject routes to find the loopback and the vMX. If you leave it to not set, we won't provision those routes. So let's go find our route tables. And you can see here, nicely labeled, the private route table that OpenStack is using. And the same for security group. We need security group rules to allow the SG of the virtual MX to connect and talk to the SG of the Contrail controller and worker. So again, if you specify it, we'll do that work for you. If you leave it to no set, then you're going to have to configure it yourself. And this is really so this stack can be used in different setups that aren't always an OpenStack and don't always look exactly like this. So let's go and find our security groups. Again, they're clearly named. One of them is for Contrail command and the other is for the OpenStack instance. And that's the one that's going to talk to the vMX. Okay, that's all I'm going to change. I'll leave everything else to default for this demo. Let's click next, next, and let's create the stack. So this stack is going to deploy services into your existing OpenStack. So it'll be ready in a few minutes and then we'll cut back to the video. The stack's completed. As I mentioned, it just takes a few minutes. But if we go look at the instances, you'll see that in fact the vMX is still coming up. So you can see here, here's the bare metal test instance, and here's the Contrail controller and OpenStack instance that we deployed previously. Here's our SDN gateway, the vMX, and here's the Contrail command we deployed previously. But if you give this vMX instance just one more minute, checks here are going to fail. And this is because the vMX actually takes some time to come up. So in short, even though the stack's finished, give it 5 or 10 minutes. I'll show you how it looks in a moment when the checks show has failed. And there you go, you can see that about a minute after the vMX has come up, it's now showing initializing. It will go through checks 1 of 2, 2 of 2, and in a good 5 or 10 minutes it will come back to the green tick and the 2 of 2 checks. And that's the point where you can log into the instance. So you can see that we've waited a good 5 or 10 minutes and the SDN gateway is showing 2 of 2 checks passed, so we're all ready to connect. And I know there's probably quite a few Junos fans watching, so before I go back and follow the wiki, let's just connect to the instance. Also, if you look at the AMI that I used, you can see that I'm running an R19.4. So this is available publicly on AWS. So if we go back to the stack, click the SDN gateway stack. As ever, I've included some useful information in the outputs. So here's how you SSH to the instance. And here's the public address that got assigned. So let's connect. So my stack does include some configuration. It basically provides just enough configuration in user data for the vMX to be discovered by Contrail Fabric. So nothing fancy, but we do, for example, include interfaces and a loopback address. So back to the wiki, we're just going to follow the steps. We've launched the stack. So this is a complex setup. We're basically getting the vMX to act like a bare metal router on-prem. So there are a few patches that you need to include in order to get this to work. So one of them is a patch in Device Manager, which is part of your SDN controller, in this case in OpenStack, but it's always included. It's a one-line patch. I will include the details at the end, but to make your lives a little bit easier, I've already burnt an image for you and I've put it publicly onto Docker Hub. So what we can do is just log into the OpenStack instance and tell it to use the device manager from my Docker Hub. And this is built on 2003. So if you're running on a different release, as I mentioned, I'll include the one-line patch at the end with the steps to generate your own Docker Hub image. But for today, you can just follow these steps, which we're going to do now. It says SSH to your OpenStack controller node. Well, I'm sure you already know how to do that, but if you've forgotten, it's in the outputs of the all-in-one OpenStack CloudFormation. So this is telling you how to SSH in. Sudo bash, and then in the wiki, it's saying to edit this Docker Compose YAML file. So let's VI it. Let's search for Device Manager, and that's where it tells it to load the image. So we're going to delete the old line. In fact, I can grab the whole line. And we're going to paste in a new line. I'm using the same name for the Docker. I'm keeping the 2003-33 tag, but I've added a -v3, just so you can tell that you're using the image, the packaged image from my Docker Hub. Now we need to tell Contrail to redeploy just a few of the Dockers in order to pick up the patch. This isn't going to wipe your database or anything like that. And there you go. Just to be 100%, you can run a Contrail status if you like, which will tell you that it's come back up. You can see just a few of the Dockers there have been up seconds. All good. Actually, I missed the patch before. So as well as the change to Device Manager, we also need to connect to the OpenStack cluster, and we need to change the encapsulation priority order. So let's go take a look and I'll explain why. So you go config, global config, edit, and here you can see the encapsulation order. Now your deployment would have MPLS over UDP at the top, MPLS over UDP isn't supported on these vMXs. GRE is. So you need to change the order to match the screen and what's included in the wiki. So first choice should be MPLS over GRE, which is going to work quite nicely. Fabric's going to be able to provision it. It's going to function just fine in AWS. VXLAN and MPLS over UDP right down the bottom because we really don't want to use it in this setup. So I'm just going to, well, I can save. I haven't changed anything. And this is how your setup needs to look. So we've changed the order for our tunnels. We've patched Device Manager so that it works with a vMX. We've got one last change. So when Fabric configures the vMX as a brownfield gateway, it has a bug. It's going to throw an error saying that it can't find a particular policy, and the name of the policy is related to the networks that it creates. Well, it isn't creating that policy. So whilst we look at fixing that, a really simple way to get around it is to copy paste my example policy. So let's paste this into the vMX, and this will be our third and final patch. Okay, so our changes are committed. The commits can take a few minutes. So this stack deploys the vMX in what's called light mode. It's as small as it can go. So I'm running it in light mode really to save money. I don't want to deploy a large instance with lots of cores because it's going to cost you to run it. We've configured to the point now where we can just use the platform normally. So we're going to connect to the Contrail command GUI, and we're going to use Fabric to do a brownfield discovery of our vMX. It's very simple to do this. So in order to get the Contrail command web GUI, if you can't remember it, again, just go to the OpenStack CloudFormation and look at outputs. So I'm using Firefox. There's our cluster, admin, Contrail 123 was the default in the OpenStack cluster. And what we're going to do is go to infrastructure and fabrics. And this is where you can build fabrics to configure data centers. All we're going to use Fabric for today is to configure an SDN gateway in that vMX in AWS. So again, following the steps in the wiki, create. You get two options, new fabric, this needs ZTP, or existing fabric, and this is what we're going to be using today, a brownfield configuration. This is because the vMX is already deployed. Provision, and heading back to that wiki, I've given you some example config. So you can change names, but first run, copy paste. We'll leave the ASN. These are the node profiles, so you can just leave these, they don't slow it down, but one of these is the MX. This is the one that we're after. The login and password for the vMX. So in the stack, if I just show you, in parameters, you'll see this very long password. In fact, it's not going to display it. It's a secret password. What that is, if you look in the stack itself, is an MD5 hash of the same password we're using in OpenStack. So that's why I say user is Juniper and password is the same as our OpenStack password, just because that's what I configured in the stack parameters. You can change it. And this, by the way, in user data is our netconf user. Okay, management. So for management subnet, this is the FXP0 subnet. So I'm just going to populate this and I'm going to show you the diagram again. So I'm just specifying the /32. If you put in a /24, it will run for every single IP looking for a way in. It's going to take a while. If I give it the /32, well, I already know what it is because I configured it in the stack. It's going to be a lot quicker. And then it's going to ask for the loopback. And if you remember, I showed you earlier that I am provisioning a loopback address on the vMX as it comes up. And all of these IP addresses are exposed as parameters in the stack. You can change them. So if we go and look again at the wiki, remember this diagram? Here's the vMX. This is the FXP0 address. And this is the private, the GE000 address. So these are the addresses I just pointed to, and I did it with /32s because I know exactly what they are. But if you want to sit and watch it scan the subnet, specify this one as a /26 and this is a /26, and it will run through them. And then next. Okay, job started, and Contrail command is scanning its way through that one IP address in order to figure out what's at the other end. When it manages to log in, it's going to gather data on the vMX and figure out what it's got. This doesn't take long, just takes a couple of minutes. So you can see that the vMX has been discovered. It's still gathering a few facts, so we need to let it finish fully. So you can see here that the discovery has finished. We found our vMX, we've gathered information about it, and you can now click Next. So on this screen we need to assign roles. If you look at the wiki, we need to assign a physical role of spine and a routing and bridging role. There are two, DC gateway and route reflector. So you click Assign Role on the right, spine, DC gateway, and down the bottom is route reflector, assign. And then auto configure. So again, this doesn't take long, just 1 or 2 minutes, and it's going to say it's done. But in fact, it's still pushing that configuration down to the vMX. We're going to see that. So it says finished. Click Next. Click Finish. And there you go. It says it's active, ready to go. And it knows it's ASN, it knows the loopbacks, it's done a brownfield discovery. But if we go back to the wiki, you can see here I've said to confirm that Fabric Manager has finished, check your BGP status. So it will take a few minutes. It takes 2 commits. So let's log in to the vMX. And if I do a show BGP summary, you can see the first commit hasn't created BGP yet. The second creates the peers towards the Contrail controller. So be patient. Give it probably another 4 minutes and we'll return to the video. Okay, so it's been a couple of minutes and you can see in the BGP summary BGP is coming up, but we still don't have a peer. The peer is added on the second commit. So another 1 or 2 minutes. Okay, so at this point you can see BGP is up, but it's also configured a peer into the Contrail controller, because remember the controller is managed by Contrail command, so it knows the IP addressing, the ASN, and it knows how to configure it. And BGP is established, so at this point we're all ready to go. Just for fun, if I do a show route, you will already see that the vMX knows about the Layer 3 VPN routes for the instances that we're running inside OpenStack. So let's return to the wiki. We've done our summary, and the next step is to extend the test network net1 to the physical router. So let's go back to Contrail command, overlay, virtual networks. There's the 2 OpenStack networks. And then the fields to set are in routing and bridging. Give it the ASN and target that's in the wiki. I'd already filled it in, but you can see it here. 64512 and 1001. And then go down to advanced. You need to extend the network to our vMX physical router and click external. External I'd already ticked, but you need to tick it. And then save. And it's going to push another commit out to the vMX. And this commit is going to configure net1 in the vMX so that the physical router has the other end of the config. So at that point, the OpenStack net1 instances are going to be able to talk to the vMX. So let's give it a couple of minutes and then return to the video. So if we just take a look at the config that's been pushed so far, that extend to physical has created a layer 3 routing instance, and the name is Contrail net1. So this is the name of the OpenStack network, so it's pretty easy to see what's going on. You're also going to see layer 2 configuration, and then further up we can see the BGP config that was pushed, And here, dynamic tunnels, you see it picked up GRE, and that was the change that we made in the Contrail GUI. That our preference is to use GRE because we know this is supported on the vMX. Okay, so let's go back to the wiki. So at this point, our OpenStack instances, which are actually sat inside this guy, and we'd have MPLS over GRE coming out to the vMX with some BGP control plane. And these guys will be able to talk to the vMX. But I want them to be able to route all the way to our bare metal instance. So there's a whole bunch of ways to get VRFs in overlay to talk to underlay in a vMX. I mean, if you Google, you will find a gazillion ways to do it. But just for this demo, I'll show you how I decided to do it. So I'm going to use rib groups, and I'm going to tell it that it can leak routes in a policy statement between my VRF and INET0. And then I'm going to place my bare metal instance into INET0. Okay, so let's copy paste the config. And let's go put that straight into the vMX. And this will tell it that those overlay instances in OpenStack can connect to INET0 and any instances sat in underlay. The security groups have already been configured for you in CloudFormation, so you can take a look. There's nothing fancy there. They're pretty much open for the bare metal subnet. So now what's left is to test. So a really easy way to connect to instances in the OpenStack is, okay, I'm logged into OpenStack here. If you just copy paste that command, there's a Docker called nobolibvirt, and you can run version commands in it. So you can see when I run it that I've got 3 instances. These came from the steps for the OpenStack wiki. And I've connected to the OpenStack GUI here just so you can compare and see what's going on. So if I go compute instances, these are the 3 instances that we ran in the OpenStack wiki. And these instances belong to 2 different networks, Net 1 and Net 2, and you can see that these 2 are in Net 1 and this one is in Net 2. So we're looking for a 192.0.2 address. So again, go back to the wiki. I've given you an example of how to get console. So console 3, the 3rd instance, these are Syros, so login is Syros, and the chap's obviously from Chicago, where I used to live, because it's Go Cubs Go. So ifconfig, yeah, you can see 192.0.2. So we're in Net 1, and it's Net 1 that we've just stretched. So this guy should be able to connect all the way through. This guy's a VM in here, and it should be able to connect all the way from overlay out of this port to this underlay EC2. So the question is, where's the underlay EC2? So I'm using DHCP for this guy. I'm not specifying the IP address. So let's go and see which IP the underlay test instance got. So there it is. There's its IP. You can see it's not the same subnet. You're not going to get layer 2 services in AWS as a rule. Public clouds are routing. That's why I'm using VRFs here. Okay, so this is the instance in OpenStack. And there you go. So that ping is creating an MPLS over GRE tunnel. Let me do it with the diagram. It's just created a tunnel this way from the VM through the vRouter all the way into the vMX. The vMX has terminated the tunnel, and the rib group has leaked the routes and allowed the VRF to route on to the bare metal subnet. Now if you look at this design, you know, I've only connected port GE001 as a bare metal, but this is a straightforward MX. If you look at the stack, you can have up to 10 interfaces. So you can connect 001, 002, 003 and do what you like. Also, I have a router here. I use a router because I don't want to play around with these instances DHCP. I just want them to be straightforward instances. Their default route will point them off to their route table, and it's that route table where I then tell them come back through the vMX. So you can attach additional subnets here. And you can put additional bare metal instances, hundreds and hundreds of them, and they will all connect to your cluster. And what I'm going to show you in the next video is that using Greenfield, we can do something even wackier. We can kind of deploy huge on-prems and stretch virtual networks out to AWS, and then terminate those virtual networks, route on to EC2 instances. So anyway, I'll show you that as a separate video. That's all I'm going to do for this video. I have shown you in the wiki how to ping the other way. So how to, from the MX, to connect to the bare metal instance, and then to ping in the other direction. I'll leave that as homework. And in addition, you can even SSH directly in to the other instance. The other instance is using a key, so you're going to have to drop the key here. Remember, it uses the key that you specified in your CloudFormation stack. It's an Ubuntu image, so it's going to say no key. Again, homework. But you can see I have full connectivity between an OpenStack in AWS with VMs in overlay using a vMX SDN gateway to talk to EC2 instances. So pretty crazy, and thanks for your time.